Hey there, welcome to Learning Labs. Today we're in meteorology and science, and we're talking about chapter 1, which is all about astronomy. Let's jump right into it. So within meteorology, on this landing page, you'll find three chapters: astronomy, weather, and climate. This chapter, chapter 1, we're talking about astronomy, which is going to be talking about Earth and its neighbors and the whole entire solar system. So let's jump right in. Chapter 1, astronomy. The main idea with this chapter is to learn that there's a solar system that Earth is a part of. The solar system consists of 8 planets, as you can see here. There are many moons and many other objects orbiting the sun. Here we have the planets. As you can see, Mercury and Venus are closer to the sun. We have Earth in the Goldilocks zone, best place to live. We have Mars a little bit farther out, Jupiter, Saturn, Uranus, and Neptune. Now, when I was growing up, they had Pluto up there as well, but Pluto is no longer considered a planet based on its consistency as well as orbiting properties. So, what is our solar system? The solar system is the sun and all the objects that are traveling around in the orbit. Okay, it's circling it. As you can see in this picture here, the yellow is the sun and those other things are circling it. It's orbiting. Okay, the objects around the sun include the 8 planets, and they travel a path that's predictable, and it's not an exact circle, but it's like an oval. Okay, what orbits Earth? A moon orbits Earth. Orbit is a oval path that circles or follows or goes around a object. In this case, it's the sun. The sun has gravity. It pulls in the rest of the planets and circle it. Humans have decided that one orbit around the sun is equal to 1 year, and one Earth year is 365.25 days. Okay, that's why we have a leap year to calculate for that. On the right, you can see average distance to the sun and then how many days it takes to orbit the sun. As you can see, Pluto is 90,000 Earth days to orbit the sun versus 365 days for Earth. And then as you go even closer to Mercury, it takes even less time. So what keeps the planets in the orbit? All right, there's 2 things at play here: gravity and inertia. Gravity depends on 2 measures. You have mass and you have distance. Okay, the more matter, the more molecules compacted inside of an object, or the mass of an object, the greater its pull. Okay, so if you have a planet and it is packed with heavy metals like iron and super dense like lead, it has more mass. The more mass it has, the more gravity it has. More things are attracted to it. Something like Jupiter looks humongous, but it's mostly made of clouds and liquid. So it has less mass. So it has less gravity. Okay? The sun is a superstar, super mass. It has a lot of gravity. So things stick around it. Okay? But as you would think, if it had gravity, just like how I'm staying planted to the Earth, the planets would go straight into the sun. How does it not go into the sun, but it goes around it? That's our second factor, inertia. Inertia is the tendency of a moving object to keep moving in a straight line. Okay? So without gravity, the planets would just keep moving in straight lines, just leave the solar system. But gravity steers the planets just enough to stay within the orbits. Okay, it's pretty cool. Together, gravity and inertia keep the planets in their orbits. Pretty cool, right? So this diagram here shows exactly how it would work. So we have gravity that pulls directly to the sun, and you have inertia is pulling away. So the average of both those velocities is your orbit. What makes a day? At any point in time, half the planet is facing the sun. If half the planet is facing the sun, half the planet is not facing the sun. The side that faces the sun is in daylight. So not only is it orbiting the sun, but it's also turning. And some faces the sun at different times. Okay? The length of day or one complete day to night cycle depends on its rotation speed. What the day affects is how much light and warmth the planet receives. It's very close, it gets a lot of that warmth. It might be too hot and it scorches the planet. So this example here, 1 meter squared on Mercury, which is very close to the sun, and 1 meter squared on Pluto, which is impossibly far away from the sun. Mercury, 1 meter squared, the same amount of space on the planet, receives way more energy, way more heat, way more light than Pluto, even though it's the same size on the planet, just because Pluto is incredibly far away. The moon, what's it all about? 400,000 kilometers away. No water, no air, no atmosphere. Right? A little bit different than Earth. Craters from old asteroids and meteors hitting the moon and protecting Earth. It has gravity, but it's low in mass, so it has less gravity. But enough gravity to stay within Earth's bounds in its orbit, but pull the water of the oceans slightly. It's pretty cool how you can see it here. The moon rotates around Earth, and its gravity pulls the water and creates high and low tides. Ah, yes, moon phases. So here on this diagram, you can see all the phases of the moon. How does the moon get a phase? By the way, the moon doesn't produce any light. So how can we see the moon at all? It's because the sun's light hits the moon and reflects down to Earth in our eyes so we can see it. How we see the moon depends on where the sun is and the shadow being casted. Light being reflected and shadows. So if you look at the diagram here, if the Earth is here, the moon is here, and the sun is here, the light from the sun hits the back of the moon and creates a shadow on Earth. That's an eclipse. If the moon was on the left side of Earth, sun hits the moon, we see half the moon, right? And it moves on like so. A full moon is when the moon is back here, and the sun hits it, and we can see the whole face of the moon. All right, that is chapter 1.1, all about Earth and its neighbors.